So here we want to find from the standard normal distribution. Standard normal means the normal distribution for z-scores. Mean is 0, standard deviation is 1. Find the probability that a z-score is more than 1.57. Right? So more extreme than that on a right tail. And I have the greater than. So usually before I whip out a calculator, I draw a little sketch, make sure I got my brain on right. Because the calculator only does what I tell it. I got to figure out how to tell it the right thing. So this is how I double check. So again, standard normal means normal distributions for z-scores, which puts 0 in the middle, and 1, 2, 3 standard deviations on each side captures most of whatever data I'm looking at. So 99.7% of data lives in this range. I was just given a z-score of 1.57. So here's 1, there's 2, so that's right about here. So that's my z-score, 1.57. So I want to know, what is this right tail probability right there? So this is like a p-value. So let's see, I can estimate it. So 95% would be between 2 standard deviations, which puts 2.5% in the tail. This is inside of that, which means the tail is going to be bigger than 2.5%. So I get a rough estimate. Let's go over to the calculator and find it. And shift desktop. So first I'll do it in stack key because that's the easy way to do it. So I can just reset this, or I could have just turned off the tail. I have the right mean and standard deviation. I always want to double check that. And this time I want a right tail. And then we plug in the correct number at the bottom. So the numbers on the x-axis, those are things like z-scores, or maybe a body temperature or amount of lead, something like that, some measurement, or maybe a proportion. The numbers up top here, those are probabilities of something happening, which could be, a p-value, or it could be part of a margin of error. So I'm entering a z-score here. Mine was 1.57. And so I get 0.058 is the probability, which is about 5.8%. All right, so according to stack key, normal calculator, we found that this right here is about 0.058. And sometimes we state these things, this could be a p-value, as decimals. Sometimes we state them as percents. Pay attention to the fine print in the problem you're working on. So maybe my answer is 5.8 if I need the percent symbol. Maybe it's just 0.058. Now the problem on the spreadsheet is the spreadsheet NORM.DIST always wants to do the left tail. And the thing is, the left tail and the right tail always add up to 100%. So on a spreadsheet, to get a right tail, I have to calculate 1 minus the left tail. So that's the trick there. So that's one reason a spreadsheet's a pain in the ass, or excuse me, pain in the butt, compared to stack key. Stack key is quick and easy, but it doesn't give me a lot of decimals. Sometimes I need more for remote probabilities. So let's go try that in the spreadsheet. So let's come down here. I'm just going to copy, say all of that, lower. And this time my z-score is 1.57. And what the straight NORM.DIST does is it gives me the left tail. Okay, so if the right tail's about 5-6%, then the left tail should be about 94%, because they have to add up to 100%. So to modify this to be a right tail, so now I'm going to put greater than whatever z-score I want. Over here in my formula, I just, in front, between the equals and the NORM.DIST, I just do a 1 minus. And then I get the one I want. So I'm just going to put that in my notes here. So this calculation is 1 minus the NORM.DIST. And that gives me a tail. A little bit. Ooh, wrong box. And you can see I get the same number as stack key with a whole bunch more decimal places. So again, sometimes stack key doesn't give me enough accuracy, so I have to switch to a more powerful calculator. But the thing I like about stack key is it gives me a picture of what's happening, which I think is better. So they both have their pros and their cons.